A car starting from rest accelerates at the rate f through a distance s, then continues at constant speed for time t, and then decelerates at the rate f by 2 to come to rest. If the total distance traveled is 15 years, then now here we will draw the graph between velocity versus time for the given data. This is the time and this is velocity. Now the body starts from rest and it is accelerating with acceleration f. So constant acceleration means this will be the graph between velocity versus time. Assume it is accelerating for a time t1. Let's take this is t1. After that it is going to maintain constant velocity. It is going to maintain constant velocity for a duration of t. So assume this is duration of t. After that it is going to decelerate with deceleration f by 2 and it is coming to rest. So that means velocity will become 0. Okay. So here acceleration is f, here deceleration is f by 2. Now we know that velocity is equal to u plus at. That implies if you use this equation for the first case, let's divide this into three cases. This is the first case, this is the second case, and this is the third case. In the first case it is accelerating, in the second case it is moving with constant velocity, in the third case it is decelerating. So in the first case velocity is equal to initial velocity is 0 plus acceleration is f and time duration of time is t1. So final velocity I can say this is equal to f into t1. Now second case it is going to maintain constant velocity, that is nothing but f into t1. Third case it is going to decelerate with deceleration f by 2. Now, so let's take this duration equal to t dash and this angle equal to theta. Now I can write tan theta is equal to f into t1 by opposite side by adjacent side, nothing but t dash. Here tan theta will represent the slope. Slope of velocity time graph is nothing but acceleration. So in the third case acceleration is nothing but f by 2. So I can write f by 2 is equal to f into t1 by t dash. Here f will get cancelled, so that implies t dash is equal to 2t1. So this t dash is equal to 2t1. Now he has given the distance traveled in the first case is s. So I'll use s equal to ut plus half at square formula. So distance traveled in the first case is s is equal to initial velocity 0 plus half into acceleration f, time duration it is t1. So t1 square. So that implies s is equal to half into f into t1 square. Now we'll calculate the distance traveled in the third case. Now area under velocity time graph will give the distance traveled. So here area is nothing but this is a triangle, half into base. Base is nothing but 2t1 into height. Height is nothing but ft1. 2 will get cancelled, so is equal to f into t1 square. So here area of the third case is equal to ft1 square, nothing but distance traveled in the third case. Now distance traveled in the second case, here velocity is constant, so that is f into t1 and duration is t. So that implies distance traveled is equal to velocity into time. Since velocity is constant, distance traveled is nothing but velocity into time. So f into t1 into t. Now since here s equal to 1 by 2 ft1 square, I can write ft1 square is equal to 2s. So here ft1 square is equal to 2s. he has given total distance traveled is equal to 15s. So that implies 15s is equal to distance traveled in the first case, nothing but s, plus distance traveled in the second case, nothing but f into t1 into t, plus distance traveled by the in the third case, nothing but 2s. So that implies f into t1 into t is equal to 12s. In place of s, I am going to substitute this equation. So that implies f into t1 into t is equal to 12 into half f t1 square. 2 1 ja, 2 6 ja. F will get cancelled. T1, here one T1 will get cancelled. So that implies T1 is equal to T by 6. But they are asking the relation between S and F. So they are asking us to calculate S value. So from this equation, I can write S is equal to half into F into T1 square, where T1 is nothing but T by 6 whole square is equal to half into F into T square by 36 is equal to 1 by 72 into Ft square. So S equal to 1 by 72 into Ft square.